Okay, here's our example number 4. Okay, so looking at the figure, we have a screw eye, and from that body, there are two forces, F1 and F sub 2. We have 100 Newton and 150 Newton. Take note that each of the forces are applied at a specific direction. The F sub 1 is at 15 degrees with respect to the horizontal axis, while the F sub 2 is applied 10 degrees from the y-axis. So in this problem, we are to determine the resultant force. Resultant force means we have to add F sub 1 and F sub 2. Okay, so if you could recall, force is a vector, so which means it has both magnitude and direction. So in this case, that will be our unknown. So if we draw an FBD of this given situation, so the forces will look like this. Okay, so we just have simplified it. We have drawn here the 100 Newton, this one, here, this one, the 100 Newton, and the other one here, 150 Newton. Take note, here is the direction applied and the 15 degrees based from the x-axis. Now, what our required here is the resultant force, which is symbolized as F sub r. Okay, now if you could observe, class, we have drawn a parallelogram. Okay, for that we will be able to solve it using the parallelogram law. Recall, that's our method in solving vector addition. Okay, so in order to just draw a parallelogram, so of course let's make a parallel line which is parallel to our 100 Newton, and here it is. Okay, and while on the 150 Newton, the parallel side is this one. Okay, so forming a parallel or parallelogram. So the line, the diagonal of that parallelogram represents our F sub r. Now, take note, class, that in order for us to solve for the value, so we need, of course, the values of the angle. Now, the given angle that we have is only 15 degrees, which is with respect to the x-axis, and the other one is with respect to the y-axis. The problem is the angle that we need is the one inside, okay, which is the theta. Here is because that will serve as our direction, or it will lead us to the direction of our resultant force. It's because, class, this is our F sub r, right? This is the line, or this is the position of our F sub r. So how are we going to describe this? Of course, using an angle. And in order to do that, so we need to have this value, which is the theta. So in order for us to solve for this theta, okay, we need to apply our formulas, of course, the law of cosines, or maybe the law of sines. But before that, of course, we need also other given. It's because our given only is this one, okay, this part right here, this side, and this one. Take note, class, that this part is just the same here, which is 150 Newton. Why are they equal? It's because they are parallel. Okay, once the sides of a parallelogram are parallel, of course, they will have the same value of magnitude. So if it is 150 here, so this one here also is 150. Okay, now take note, class, that if this is 15 degrees, okay? If this is 15 degrees and then this one is 10 degrees, this total here is equal to 90, right? So in order for us to determine this angle here, this, okay, the angle of the side of a parallelogram, or this one here, okay, so we will subtract, of course, 15 and 10 from 90 degrees. That's why we have here a solution which is 90 degrees minus 25. So this 25 class came from the sum of 15 degrees and the 10 degrees here. That's why we have here a 65 degrees. 65 degrees class is the angle here, this one. Okay, the one that covers here. Eto. They are just the same here, that is 65. Now, our target is only the half of this parallelogram, which will we used as our triangle rule. Okay, so of course, 65, we cannot or we don't know if this side here is really half of this. It doesn't guarantee that this diagonal is in between, means that the angle here is equal to the angle here. Okay, what I meant is it doesn't tell us that we should divide 65 degrees by 2. Hindi ganun yun, class. Okay? Hindi ibig sabihin na etong linya na to is nasa gitna, is ibig sabihin nun is yung angle dito is the same din dito. Hindi. But all we know is the total here is 65 degrees. Can you follow? Now, our target is this angle here. Okay, so in order for us to apply the law of sines, okay, we need two angles. Two angles, or pwede rin na two sides, one angle, pwede rin yun, or two angles, one side. Okay, so what we will solve here is this one. Okay, this angle here. So what is this value? Okay, now if you recall, class, a parallelogram has a total of how many angles? Okay, how many angles? If a triangle has a total of 180 degrees, obviously our parallelogram has a total of 360 degrees. Okay, 360 degrees. So since this part right here of the parallelogram is 65, this one, and the other side is also 65, it's because, class, they are just equal here. Okay, this side here at point A and this side here are just equal, so that means this is 65 also, 65 also. So we have here 2 times 65. Okay, so what is our target here is the value of angle here, which is also equal here. Okay, that's why, class, the formula here, what we did is from 360 we subtracted 2 times 65, or dalawang 65. Okay, so whatever the value that we have get, that is the sum already, sum of this angle and this angle. So since they are just equal, that's why we have divided by 2. Did you get it? Again, this 360 is the total angle of a parallelogram. Now, since we have already value of 65 degrees, which is the angle of both sides here and here, so the remaining unknown is this one, this part right here, which is also equal. Equal yan, class, is because they are parallel. So subtracting from 360, so whatever the value taken from here, dito lang muna ha sa numerator, that is the total angle left in the parallelogram. Now, since, like we have said, they are just equal, so we will divide it by 2, and that is where we get this 115 degrees. Again, that 115 degrees is the angle here. Okay? Now, if we isolate the part which is the triangle, here it is. There. We have there the 115 degrees. We have there the F sub R. We have the 100 Newton, the 150 Newton. And here's our angle, theta. And here, the another angle which is the phi. Okay, that is the angle phi.